Back to another video of Just Code It, and today we'll be doing 2460 apply operations to an array. This is today's Leetcode daily problem, and I'm excited to share with you the first day of March. So let's read the description. You are given a zero index array nums of size n consisting of non-negative integers. It says that we need to apply n minus 1 operations in this array where the ith operator, the zero index, will be applied to the following ith element in the nums. If the current element and the next element are equal, then we apply, for the current element, we multiply by 2 and set the next element to 0. Otherwise, we skip the operation. And it says after performing all the operations, we want to shift all the zeros to the end of the array. And it gives us a little example where we see 3 zeros at the first index, the fourth index, and the fifth index. And we see that all the zeros are moved to the end and all the non-zero numbers are moved to the front, while keeping the order of the elements, by the way, the non-zero elements. And it says return the resulting array. It says note that the operations apply to sequential and not allow one, so we go one by one instead of having to do it multiple times, so like if there's repeating zeros. Okay, looking at this first example, I actually have it right here on my right screen, so we can skip that for now. But let's look at the second example. Since there's no corresponding matching elements inside the array, we know that there's no operations to be done, and we just move the 0 to the end. So these are some base and edge cases that we can ask. So can nums be filled with only zeros? If so, we just return an empty array. The same array with just zeros. And will nums ever be empty? So will we always be given a valid input list? These are typically questions I like to ask the interviewer, as the constraints aren't always given to us during the interview. And with my approach, the time and space complexity, the time complexity being linear O of 1, because we'd just be iterating through the input array twice with non-nested for loops. And for the space complexity, since we'll just be using pointers, it's just going to be constant. So for the first step, we'll first like to iterate through the nums, and whenever we do, and whenever the current number and the next number are equal, we'll update the current number multiplied by 2 and the next number by 0. We'll set it equals 0. And then for the second step, we need to move all the zeros to the end. So on line 17 to 21, I gave a little representation what we're doing do the first iteration. So you see, starting at I, we like to move it across, and so whenever we do encounter two numbers, corresponding numbers that are equal to each other, we multiply the first one by 2, and then we set the next one to 0, as we did for this example. And now I move the index pointer down because we're not doing an operation here. And so we see at here, both the ones are equal, and so the current one we multiply that by 2, and the next one we set it to 0. And now we're given our original input, so our non-move 0 input. And so here is where our lead pointer and our swapping pointer, I and j respectively. And so just to demonstrate to you how it would work is, whenever I finds a non-zero number, we would commence swapping the numbers. So let me reset this for you guys so you guys can see. So for example, since I is at a non-zero number, we would commence swapping, right? But it would be in place. This is just to move our j pointer in place. So since I is at a non-zero number, we do the swapping, as you can imagine, and then we'll move I by 1 and also j. And since I is at another non-negative number, we'll move I by 1. And imagine this swapping, but it would be in place, and then we'll move j by 1. And then I would continue forward because I itself is the point is going to be is going to do automatically, while j is manually inside of a for loop. So you can imagine, like, this is just the for I in range. And since here I is at another non-zero number, and so we'd commence swapping, and then we're 2 and 0, we swap, and we'll move I by 1. And now we'll continue forward into the end of the list, and we see just fit with just 0 zero numbers, our J pointer would remain the same while I executes outside the loop, exiting outside the loop. So like first, we will iterate through the loop and update the values and complete the operations whenever this two numbers next to each other are equal. So for I in range, the length of nums, let's just set it to n minus 1. If the current number is equal to its neighbor, nums at I, we know that we're multiplying this by 2. And for the next number, we'll just set it to 0 equals 0. So this would do everything on line 17 to 22. And now for our second part, which is swapping the zeros, we'll just create our swapping pointer. So I'll just call it J, set it to 0. And for I in range, the length of nums, if nums at I is not equal to 0, then we'll commence the swapping. In Python, we can do it all in the same line. How I'm doing it here, nums in J is equal to nums in J and nums in I. And now we'll just update our J pointer. And this should be all of the code. Let's see if it runs here. So let's check it here. I have to set this I plus the current value plus 1 at J. So let's run it and see what it gives us here. Great, it looks like it passes all these 2 test cases, and let's see if it passes everything on the left side. 5,000 people are online solving this, so hopefully it can help some of them out when I post it. So beats 34%, and it passes all the test cases. If there's any more questions that you guys would like me to answer for you guys, just feel free to leave it down below. And thank you so much for watching, and please subscribe as I continue to post daily Leetcode videos. Thank you.